We've been hammering away at this problem for 20 years, and we now have more tools than we ever have to be able to address it. And because of that, and because of our growing understanding of the molecules and genes that are necessary to manipulate, I think we're closer than ever. Research in birds is really important because they allow us to study the system in which this spontaneously happens. We're really fortunate as a group of biomedical investigators to have this opportunity to study an animal that readily regenerates hair cells, and this allows us to determine what sort of mechanisms they use and hopefully apply those to initially animals like mice to try to trigger the process in them, because you know that most mammals don't regenerate, and then hopefully bring that information into humans. We're trying to dissect the mechanisms that they use to form new hair cells spontaneously. This means identifying different genes that are used at what time, trying to find signals that can trigger those genes to turn on or off. And then we also study mice, and so what we do is we take the tools that we develop in chickens and we translate them into mice. At this point, we're primarily working in culture with both of these animals. So we actually dissect the inner ear organs and apply different chemicals to them to see if we can increase the amount of regeneration that happens. But we hope to move into stimulating regeneration in a live animal, because ultimately that's what we want to be doing. The Hearing Restoration Project is really important because it brings scientists together who otherwise would work independently. And what this does is it builds a synergy between all of us that is so critical for hastening progress. We really have a challenging puzzle to put together, and it's much easier if we work together in one room to solve this problem, to put the puzzle together, than in separate parts of the country and the world.